So today we are going to start unit number 5. Uh, so as I told you that in unit 5 we are talking about the runtime environment. The content are completely theoretical. Whatever we have learned in unit up to unit 4, that is 1, 2 and 3 and 4, all that we are, whatever the knowledge we have learned up till now from up to unit number 4, we are applying that knowledge. Uh, we are collecting all the things. For example, we know symbol table is there. Then we are trying to understand in this unit what is a compile time, what is a run time. See, we have seen a few examples of the intermediate code, right? So in intermediate code, we are using some temporary variables like T1, T2 for storing the intermediate results. So actually, uh, during compile time, compiler generates virtual addresses, not actual addresses, for various uh, variables, identifiers, or structures we are using in our program. Uh, for example, our program may have multiple large number of procedures, functions, and every function has some name, procedure has some name, function has some return value or some variable return x, means that particular function is returning some value of x. Like in same way, a procedure can have different means return number of return values. Means as you know, perhaps you are already familiar that in C, if you take the concept of function, then function returns only one value. Even the main function is there, so it returns only one value. You may write many functions inside that main function, but all functions return one value. But a theoretical concept is that a procedure can return multiple values. It depends. So there might be some arguments we pass to the procedures. So like A, B, C, D arguments are there. Then there is no restriction that some arguments may be integer, some arguments may be float, some arguments might be some pointer or some location. So that is there. Same cases with the function also. Means arguments can be there. We call them as variables, local variable or global variable. So they can be of different types and they may be stored at different places in actual memory. But during compile time, the compiler, while we enter making the entry into the symbol table, it's tentatively generates some address that is called as a virtual address. It is not an actual address. So every variable which is stored, this information is stored into the symbol table. Symbol table contains everything about that variable or name. Name of the variable, size of the variable, type of the variable, then content of that, means the value of that variable, like that. Even a procedure name can be there or function name can be there. Means name of the procedure, uh, then number of parameters required for that procedure, uh, name of the return variables, return values, variables. So all everything is stored into the symbol table, but it contains virtual addresses. These are not actual addresses. But when we compile the program, when we generate the intermediate code, and we translate that intermediate code into actual binary code or machine code or target code, then we have to assign memory locations to these variables or names. Names Names means it can be the name of variable or identifier or name of some procedure or function. If it is a name of some procedure, uh, then whether that procedure is recursive or simple procedure, what are the parameters of that procedure, where they are stored. So all these things are maintained by something called as a runtime environment. Actually, runtime environment is not a part of compiler. Runtime environment is a part of the operating system. Operating system on which you are running that particular code, executable code. Operating system has different functions. You know that operating system loads that image into some memory. So just like image or photos or video files, so every file has some format. Some header is there, some data area is there, and some footer is there. So some control information is there. In same way, the executable image, executable image of any program has some structure. We shall see that in this unit. So that is called as a layout of the uh, program or image, runtime image. And I think you know what is the definition of process. Actually, program is simply a raw code, statement by statement instructions. That is a program. But when you run it, when you create an instance of running of that process, when you execute that process, it becomes that program becomes a process. Once it becomes a process, so every process gets something called as a process ID. I think you might have experience in your task manager or task in Windows or any operating system. There is a option. So in text task manager, you can see number of programs running into the your system, and every which are running has something called as a process ID. So that process ID is something. It is identifier given to the instance of executing programs in that operating system, because there can be multiple programs running into the operating system. So every process has something called as a process ID, PID, and there can happen that parent ID, child ID means uh, there might be main program which calls another program, that program calling another program, like that. So there is something called as a tree is there, runtime tree is there. So So that thing we are trying to understand, means we are going to understand what is the difference in a compile time activities. Actually, compile time activities are different. Compile time activity means what? Reading the source code, creating the tokens, then generating the parsing it, creating a syntax tree, then extracting the meaning of the syntax or instructions. So these are the compile time activities. But runtime activities are different. Runtime activities mainly includes uh, where, which area memory location is assigned to which variable, like that. What is the length of that area of that or length of range of that particular structure? For example, there might be structure like a student. That structure contains roll number, name, age of the student, like that. So that structure is there. It is of fixed size, just like a table. So runtime environment has to keep the track from what is the starting point and what is the ending point of that structure. So everything, that thing is managed by runtime environment with the help of operating system functionality. So let us go ahead. We shall go through some theoretical concepts. I will show the example of activation record. So this is agenda. First, try to understand what is exactly the runtime environment is there. I will be giving you the definition of that. Then we shall try to understand what is the image, what is the structure of the image of the executable program. So there are different parts, like code part is there, stack part is there, heap part is there, like that. That we are going to see what is the image of a program which is loaded into primary memory by operating system. Normally, loader is a system software which loads the executable image into the primary memory, and then we run it. Then, uh, as I told you, that we are talking about the allocation of memory allocations to particular names. Names may be name of the procedure, name of the variable, or name of some structures which are used or declared in that particular program. So it depends on the way of allocation to the names, or way of allocation of storage to the names, depends on the type of the programming language. Uh, it may be a procedure oriented language, it may be object oriented language, or the feature of particular language. For example, there might be some old languages where you cannot write a recursive program. You know what is recursion? For example, factorial of a number or Fibonacci number. Then means a program or procedure or function calls itself many times. So, so depending on the features of the particular programming language, the runtime environment is different and the allocation strategies are different. So sometimes we use static allocation strategy and sometimes we use dynamic allocation strategies. So that we are going to see here in very short. And then we shall discuss what is the activation record and binding of names. Actually, binding of names means what? Binding of names means allocating storage or allocating location to particular name. Name means anything. It may be variable, it may be some structure, it may be name of procedure, or it may be name of some function. Anything or any object in which you are using into your source code. So that is called as a binding. So again, in binding, there are two ways of binding. One is a static way, static allocation, and second is a dynamic allocation that we are going to see. And lastly, we shall see what is the runtime memory, how our image, executable image, is look like into the memory. What is the layout that we are going to see. But before going, I just want to, because there are some WhatsApp messages that some people have some problem in selecting the TEC topic. Actually, as I just told you that there are 20 topics, you can select any one. And whatever the P, C, and S is there, S means seminar, C means case study, P means programming assignment, T means demo. So you can, as per your convenience, you can change. And you have to Google just, for example, polyspace or clockwork is there. You have to just collect the material from the Google and you have to create some report. So if someone asks me, want to ask me anything about the how to select or that, you can select any. There is no restriction that you should not select this and that. You can select any topic out of this 20. I hope that you know the nearly deadline will be around test 2, 1 plus 2, 3 days plus minus. We can do it. So nobody is asking. So I will go ahead. I think last time Sonal was asking me about she is not able to uh, understand what is the meaning of these two slides. These are simple. These are the broad names. I have just given you the topics. You have to frame. You have to customize them as per your whether you are doing case study or demonstration or programming like that. You have to customize it as per your requirement. So nobody is asking. So I will go ahead.
हेलो सर।
So हाँ बोलिए बोलिए.
हाँ सर, वो जो आपने प्रीवियस स्लाइड में बताया था जीयूआई एप्लीकेशन का, तो वो
हाँ
कब तक सबमिट करना है सर?
देखिए
प्रोजेक्ट।
टेस्ट 2 जो है कि नहीं उसके आसपास में करो ना. समझो मान लो 5 तारीख को टेस्ट चालू हो रही है तो
अच्छा।
4 तारीख को कर सकते हैं या 6 या 7 तारीख को, लेकिन ज्यादा मत उसके वो वीक के अंदर में करो आप टेस्ट के ड्यूरेशन के.
ओके सर।
हाँ
और कोई भी एप्लीकेशन ले सकते हैं ना सर हम
कोई भी ले
जीयूआई
सकते. हाँ 20
ओ,
में से आप कोई भी ले सकते हैं.
ओके सर।
हाँ जैसे फॉर एग्जांपल इसमें 1 नंबर का है प्रोग्रामिंग इन याक. तो इसमें कैसा है कि आपको कोई तो भी एक या दो छोटे छोटे प्रोग्राम 10 या 12 लाइन के याक के प्रोग्राम आपको एक वहाँ पे देने के हैं. उसका एक्सप्लेन करने का है कि वो प्रोग्राम कैसे काम करता है, उसमें का उसको डिस्क्राइब करने का है और उसका आउटपुट आपको बताना है. तो आपको स्क्रीनशॉट ले सकते हैं आप अपने रिपोर्ट में. ऐसे
ओके
टाइप का
सर।
बता सकते हैं. हाँ
ओके सर।
ओके. So before going to understand what is exactly the runtime environment, just recall that we know that there are 7 pages or 6 pages. Actually, there are, and this is only theoretical concept. There are actually many pages. It depends on type of compiler. Advanced compilers, there are many advanced compilers where there can be more than 8, 9, 10, 12 pages. Even intermediate code representations are different. Means high level intermediate code representation, medium level intermediate code representation, and low level intermediate code representation. Levels of intermediate codes are also different. And then optimization is there, and then code generation is there. As I told you in beginning, in last session, that once we have an intermediate code, it may be a triplet or triple address, three address code, or it may be something DAG. Even if you have DAG, you can directly convert that DAG by traversing that DAG into assembly-like code, like move, jump, and all that. We have seen previously one example. So, so initially we generally create assembly-like code before going to the actual target code. Target code is something zeros and ones. And why we do assembly-like code? Because we know that assembly-like code is a machine dependent, but intermediate code is not a machine, it is a independent, because every machine has different architecture like 32-bit, 64-bit, and there might be different number of registers. Some machines may have 18 registers, some machines may have 32 registers like A, B, C, D, stack pointer, and so many. Means that is about the architecture, internal architecture of particular hardware. So that's why we do optimization on machine independent level, that is the intermediate code. We don't do optimization on assembly like code or target code that is there. So, so whatever I want to say is that whatever the phases are there, so during every phase has some task. For example, lexical analyzer reads the source code and identifies the tokens. It stores the token numbers into the symbol table like this. Symbol table contains all the information about the variables, identifiers, names, procedures, whatever is there inside that program. So sometimes we create entry into symbol table. In some pages, we update some entries into the symbol table like that. So, so all phases during the compilation interacts with the symbol table. They may refer some information from symbol table. They may update some information into the symbol table depending on the type of job of the particular phase. So, and something called as a error handler is there that we have seen that during syntax analysis, what we do derivation. It may be top-down derivation or it may be bottom-up derivation. If we are not able to derive particular statement, uh, programming language construct, then there might be some syntax error. So whatever that table is there, parsing table is there, we have seen in LL parsing and uh, LR parsing. So there are some gaps. So it may be missing of some comma or something or capital letter or lowercase letter, something like that. So error functions are there, which tells what kind of syntax error is there, and it prompts to the developer or programmer to be line number 3 pe falana falana error like this. So most of the phases interact with all these things. So error handler is an independent module. It is not a phase, it is a module which works with all these phases. And every time, for example, in lexical analysis, there can be a lexical error. In syntax analysis, there might be some syntax error, grammatical error. In semantic analysis, there might be some type error. Type error matlab kaise? If there might be addition of A and B, A is a integer and B is a boolean. And if you try to add it, then that is a wrong. So that is called as a semantic error. So all the phases interact with these modules, error handler. And symbol table is not a module, it is simply a data structure. It is simply a table, as its name tells you. Table has some fields and it contains information about all the names. So with this overview of the compilation process, we shall begin. Now, as I told you, that runtime environment is a concept. It is not something, it is an environment. Some certain things are there we have to consider. So whatever the executable image or run image is there, it is handled by the operating system. So it is under control of the operating system, because in operating system there are many processes running into the system. There might be Prince process, there might be some Chrome instance running in the background, there might be Word instance, MS Word instance. So many instances are there. OS has to give chance to everyone. I think someone's mic is on, so I request you try to mute it. So it is a job of the operating system to allocate a space to the executable image or process. Now, as you know, that runtime image, that process image, you call this as a process simply, has some size, definitely. It has some size. It is divided into parts like stack area, text area, and heap area, like that, or data area. So, uh, so it has some size. Now, operating system has to load that image into the primary memory. So, depending on the availability of memory, operating system loads some part of that image, because something called as a swapping is there. So, depending on the requirement, operating system loads some part of that image. Sometimes, if primary memory is free, it is enough, then operating system can load complete image into the primary memory. But every time it is not possible. So it may bring some part into the primary memory, and we go on executing instructions as on when required. We move one part from memory out, maybe in a swap area or a temporary area, and then again we bring new part of that image, process image, into the memory, like that. So OS has a main function to allocate a space to the image. The code is loaded into the part. So that space is divided into different areas, high memory area, low memory area, like that. And lot many processes or run executable images are loaded there. And every image has something called as a starting point and something called as a ending point. So we call this as the entry points. इसका start point कहाँ पे है भैया और end point कहाँ पे है. So for example in C we use main function. So OS jumps to the entry point of particular program. जैसा main function है OS C में. So that is the beginning, and there is a brace at the end. That is the end. So execution of program is initially under control of the operating system. That is sole control of the operating system. Compiler has nothing to do with this runtime environment. Compiler का काम एक ही है कि virtual addresses generate करके निकालो, like that. और जो virtual addresses है उसको actually intermediate memory locations assign करना, actual memory locations assign करना, ये OS का काम है. So this is a theoretical. I will go through it. So runtime environment is a concept. It's a set of data structures. Runtime environment is a set of data structures maintained at runtime to implement the execution of the particular program. To implement execution of particular program. So what are different types of data structures? Some examples are stack is there. So there are different types of stacks. Runtime stack, control stack, we shall see. Then heap is there. Then some static area is there, and some virtual area is there in that memory layout. So stack is a data structure, heap is a data structure, some static area is there. It is a block of memory locations. That is called as a static area, and some virtual area is there. So, so all things are nothing but these are the data structures maintained by operating system. So please note that all these runtime data structures are maintained by operating system, not by compiler. Compiler का काम हो गया है. Once compiler generates a target code, that is a binary image, उसका काम खत्म हो गया. Then we don't need a compiler. Once we have a correct image, executable image in terms of zeros and ones, then the job of operating system begins. And that is something called as a runtime environment. So operating system uses some structures, data structures, to manage execution of particular program or process. Now the features depends on the source and the target language. Source language matlab, for example, you are writing some code in C, you are writing some code in Pascal or Java. So some language may be object-oriented language, some language may be procedure-oriented language, or some language may be something like middle-level language, like C. So every language has some features. So runtime environment depends on features of the source language. It will be C, Java, or whatever. Every language, source language has different features. We shall talk about it. So features of source language are different, and features of target language, that is the executable language, are different. So target language features are with respect to operating system, and features of these are theoretical. Features of source language are theoretical. So compiler creates and manages runtime environment. So runtime environment, as I told you, runtime environment is nothing but it is a 2 or 3 data structures. These data structures can be stack, heap, and static area. Now runtime deals with the layout, allocation, and deallocation of storages. For example, we have array. So array is a static structure. So for example, I declare A in bracket 100. So A is the name of the array variable, and 100 means 100 items in that array. So I may declare that A as an integer array. So 100 locations for 100 integers. So that is there. This is the idea. So runtime deals with the layout and allocation and deallocation. So as I told you, if there is a static thing like array or some variable, integer variable, तो उसको हमको fix एक size allocate करके देनी पड़ती है. So when there is a runtime image into the memory, and if there is an array A100, तो आपको especially 100 locations 1 2 3 4 up to 100 स्पेशली आपको अलग निकाल के रखने पड़ते हैं, पर्टिकुलरली वो एरे के कंटेंट्स स्टोर करने के लिए. So this is called the allocation. In same way, deallocation is there. For example, there can be dynamic element like linked list. तो लिंक लिस्ट में कैसा होता है कि हम ऐसा नहीं बोलते लिंक लिस्ट 1, लिंक लिस्ट 10, ऐसा नहीं बोलते. लिंक लिस्ट कंटेन्स नोड. Every node has a forward pointer or reverse pointer and some data value is there. So every node takes some space. But initially when we declare it in our program, we don't know how much nodes we require, how much linked list nodes we require, because it is dynamic. We may add elements. Suppose we add 7 elements, then it will be of size 7, like that. So, or we may delete some items from that linked list. So deallocation can be there. So it happens with dynamic data types, dynamic storage data types. For example, as I told you, array is a static, it is fixed. Once you declare, you have to whether you use or not. For example, 100 array locations are there, whether you use only 7 or 10, it means that 99 locations are wastage. It is of no use. We are unnecessary consuming memory, primary memory of particular operating system. That is there. So that is the disadvantage of static items in a program. But dynamic atoms has again some disadvantages. Means definitely we can effectively use memory, primary memory, but you disadvantage is that to handle allocation and deallocation, insertion, deletion, modification, the dynamic atoms are hard. They might be time consuming. So every atom, static or dynamic, has advantages as well as some limitations or disadvantages. So runtime deals with the layout, allocation and delocation of the storage locations, linkage between the procedures, passing of the parameters among the different, like that. So as I told you that if there is a procedure, then there are some arguments. So some arguments may be call by value, call by reference. It depends on type of the uh, uh, passing arguments. Call by name, call by value, call by text, call by reference. So, so everything depends on the features of particular programming language. All programming languages do not support all types of the parameter passing mechanisms. जैसे कॉल बाय वैल्यू है, कॉल बाय रेफरेंस है, तो सभी लैंग्वेजेस ये मतलब सपोर्ट नहीं करती. सो दैट इज देयर. नाउ before understanding what is the runtime environment, we have to go through this list of 8 items. 8 points are there. So I will read it. So runtime environment, it assumes that its target program is being executed. So that is obvious. इसमें कुछ खास नहीं है. Then this runtime environment deals with variety of issues such as layout. As I told you that every process image or runtime image has something, some structure is there. So that image is divided into parts like code area, stack area, like that. So runtime environment deals with variety of issues such as its layout. Every executable image has its layout. Then the allocation of storage locations for objects named in the source program. So this is one issue. So how to assign memory locations to the objects in a source code. So this is a job of the runtime environment. Then the mechanism used by the target program to access variables. The linkages means there might be some references by pointers. We use pointers. No matter in our program, we might not be using some pointers directly, but operating system has to use pointers to link the items, means names and its storage location. Then runtime environment takes care of the passing of the parameters. As I told you, call by value, call by reference, whatever the way is there, this runtime environment has to take care of that thing. Now interfaces of the operating system. As I told you, what is happening? Operating system itself is a program and you are executing a program. So it is also, so there are two processes, operating system as a process and your program as a process. They interact. So how they interact? So that is the issue in a runtime environment. Then sometimes we may provide some input from keyboard. We may provide some input from some file. There might be some file. Your program might be reading something as a input, as a file from some file. It takes input from that file. It may be text file and it computes something and it produces some output. So input and output can be there. So that is also managed by runtime environment. कि भाई input कहाँ से ले रहे हैं आप? Whether you are already providing input through some keyboard or you are providing some input already stored in some other file. So that thing we have to take care in runtime environment. And interaction with other programs. So as I told you that in operating system there might be multiple processes running. जैसे Chrome का एक इंस्टेंस है, माइक्रोसॉफ्ट वर्ड का एक इंस्टेंस रन हो रहा है, आपका खुद का एक प्रोसेस, and at the same time operating system itself is a process, it is also running. So there are 4 or 5 processes running inside the operating system and they interact with each other. So what I want to say in short is that every process, every executable image has its own runtime environment. If there are 10 processes, then there are 10 different runtime environments. So every process का independent runtime environment होता है. And what is runtime environment? Runtime environment is nothing but it is some kind of data structure like stack, heap, like that. So this is a diagram. So this is general layout of any process. So process is divided. Process means what? It is a executable image inside the primary memory. So it is divided into 2 parts. One is called as the outer space and one is called as the code part. And we shall see detailed of this layout later in other slides. So as I told you, it is not enough to translate intermediate code into the machine code, target code. That is not sufficient. We have to think about the how to actually allocate the memory locations to the names in our source code. And here operating system helps us. So normally every process runtime image has this broad structure. Actually, there are 7 or 8 parts are there. We shall see in other slides. But code area is there. The code area means what? It contains actual machine instructions in your image in that first part. And there is something called the outer space is there. So outer space contains other things. So it contains data related with other things. And data might be related with some variables, data related with other procedures, functions, their return values, their arguments, type of the arguments, like that. So data means that this our other space contains information about other objects like procedures, functions, arguments, like that. And actual code is stored in first part. So compiler is responsible for generating a code. And orchestration means what? Orchestration means what? It is something who manages allocation, deallocation, and binding. Association. Binding means association of names with actual memory location. So that is called the orchestration to use the data area. So there is a concept of data area, activation record. We shall see later what is that. So outer space holds all the data needed for program's execution. And code contains actual instructions, machine instructions. So I think at least up till this slide, we are clear that broadly there are 2 parts. One part contains the actual code, other part contains data. Now this is just general definition. Just go through it because we have to understand what is a runtime environment. So we can consider any program as a big procedure, and a procedure can have multiple procedures or functions inside it. So if you think as a procedure, so you can divide that procedure into different parts, like name is there, parameters are there, some local variables or global variables are there, and some return values are there, and body means actual code of that instructions of that particular procedure. So this is a broad way of understanding what is a procedure. So name means name of the procedure itself. Name means name of the variables, data structures used in that code that is there. Parameters might be a procedure or function. It might have some arguments, that is the parameters. And in code, there might be some local variables as well as global variables. that can be there. And if it is a procedure, there might be something called as a return value, because it starts up and it ends. So before ending, it should return some value. As I told you, that function returns only one value, procedure can return multiple values, it depends. And body means actual code. So procedure call means that a body of a procedure is executed. You are running from starting point of that procedure, first instruction in that procedure, and you execute instruction by instruction, one by one. The control returns to the instruction immediately following the procedure call. Now we shall try to understand what is a control, what is a flow of control with some diagrams in the next slides. Now here, I'm not going to give you a complete idea, but just imagine that this is a simple program. It is a quick sort program. So there is a name of the program or procedure is a sort. Then there is a function partition. Then there is another function that is called as a quick sort. And every uh, uh, procedure has some arguments. For example, sort is there, partition is there, then there are two arguments, x, y and z. These are the integer arguments. Quick sort is there, m and n. So we know that pivot items and all that, whatever is there. So this is a Pascal-like program, but through this slide, we are just understanding what is a formal parameter. So formal parameters are actually arguments which we pass to the particular procedure or function. So that's what I want to say here only. And actual parameters means what? When you are running some instance of particular function, then at that time, for example, 1 and 9. So it is a length of 10 items. So you divide that list while doing the quick sort and like that. So the actual value is the actual parameter you are passing to that particular function at particular time. So 1 and 9 might be the actual parameters in particular instance, because quicksort calls itself recursively again and again. So through some tree, we shall understand actual parameters matlab kya hai. Now through this, let us try to understand what is the lifetime of a procedure. As I told you, in a bigger program, there might be multiple procedures or functions. A program can contain one or two or three procedures or one or two or three functions inside it. Now, just like a variable, a procedure also has something called as a lifetime. So lifetime is a textual, it is a textual sense. So lifetime of a variable x is a portion of execution in which x is defined. So देखिए, if there are number of lines where you have declared somewhere x and there are some other lines where you are using x as a variable. For example, a is equal to x plus y, and first line is a you are declaring what is x. So all these 10 lines in that x variable is a live, it is a live. And once you lay these 10 lines, because ये 10 लाइन के पहले कुछ लाइन्स है और ये 10 लाइन के बाद में कुछ तो भी लाइन्स है. So when you leave this block, then that life of that variable expires. If you go beyond 10 lines, बाद में हमको x का कुछ काम नहीं है, like that. So every procedure or a variable it has some lifetime during when you execute them instruction one by one, like that. So when you run a particular procedure, that instance, it is called as activation. So the execution of particular procedure body means actual code in that procedure, code on that procedure. So that is called as activation. And we shall see the concept of what is the activation record. एंड लाइफ टाइम ऑफ प्रोसीजर एक्टिवेशन, तो कितनी देर तक वो प्रोसीजर रन हो रही है along with its parameters. Sequence of steps between first and last statement in the execution of procedure body, including the time spent executing instructions in that procedure, is called as a lifetime of particular procedure. I hope you got what I want to say. A procedure is a set of instructions, first instruction, second, third, and last instruction. When you execute these instructions from first to last instruction, then we say that it is a lifetime of that particular procedure. So the concept of lifetime is applicable to some variable also. For example, here variable is m, I is there, z is there, n is there. So the lifetime is live until in that particular portion of instructions. So these are the two different concepts: lifetime of a procedure or a function. Lifetime of procedure or function means what? It is the duration of first instruction to last instruction execution. ये पूरा जितना टाइम लगता है, so that is a lifetime of that particular procedure. In same way, it is applicable to variable also. The lifetime of a variable x is a portion of the execution in which that x is defined. जिस जिस एरिया में जिस जिस लाइन पे वो एक्स डिफाइन किया है और जहाँ पे भी आप उसको यूज कर रहे हैं, उतने एरिया को हम उसका लाइफ टाइम बोल सकते हैं. और एवरी इंस्ट्रक्शन हैज डिफरेंट एग्जीक्यूशन टाइम. प्लीज नोट, एवरी इंस्ट्रक्शन हैज डिफरेंट एग्जीक्यूशन टाइम. और पूरा हम सम करेंगे तो पूरा वो कंपाइल प्रोग्राम का रन टाइम हो सकता है. Now some definitions are there. I hope you just go through it. Perhaps at the end of the session, we will be able to understand what is the meaning of the activation, activation tree, activation record, and then a lifetime of particular procedure or activation and variable. So we have to go through some small definitions. So activation is execution of a procedure. That's it. So you can write in your copy. So what is activation? Activation is the execution of particular procedure. Now think in bigger way that you have a program, it may contain multiple procedures. So we call some procedure. जो इंस्टेंस को हम पर्टिकुलर प्रोसीजर को कॉल करते हैं या एग्जीक्यूट करते हैं, दैट इज कॉल्ड एज एक्टिवेशन. एंड एक्टिवेशन is stored, it is a record. The record is stored somewhere. It is called as the activation record. We shall see what is that. But the definition of the term activation is execution of a procedure. And lifetime, the sequence of the steps between first and last step in that particular procedure body. And it includes द कॉल्स टू अनदर प्रोसीजर. मतलब एक प्रोसीजर में से आप दूसरे प्रोसीजर को भी कॉल कर सकते हैं. इट डिपेंड्स. और द प्रोसीजर कैन कॉल इटसेल्फ. इट आल्सो डिपेंड्स. सो सीक्वेंस ऑफ स्टेप्स बिटवीन फर्स्ट एंड लास्ट इंस्ट्रक्शन इज कॉल्ड एज अ लाइफ टाइम. एन एक्टिवेशन ट्री, इट इज अ ग्राफिकल रिप्रेजेंटेशन ऑफ flow of activations when program is running. We shall see immediately after this slide what is that. So activation tree is a graphical representation of flow of activations. Activations means execution of procedures. And actual flow of control corresponds to the depth first traversal of that activation tree. तो जो भी हमारा एक्टिवेशन ट्री है उसको हम डेप्थ फर्स्ट ट्रैवर्सल से अगर ट्रैवर्स करते हैं तो हमको प्रोग्राम का फ्लो ऑफ कंट्रोल समझता है कि हम कहाँ पे हैं अभी. सो दैट इज समथिंग कॉल्ड एज अ फ्लो ऑफ कंट्रोल. नाउ दिस could be the example. For example, we are using a quick sort. Now first uh, we are passing 1 and 9 to the queue procedure. Then we divide it into 1, 3 and 5, 9 like this. Then again, so in this way, whatever programs we have seen in last, there was a procedure partition and there was another procedure called quick sort queue. So we are calling instances of particular procedures and along with this actual parameters. So these are the actual parameters. So इनिशियली हमने 1 and 9 दिया, बाद में उसका 1 3 हो गया, फिर 5 9 हो गया, फिर 2 3 हो गया, फिर 5 9 5 5 एंड 7 9 हो गया एंड लास्टली। तो इस तरीके से हमने कंप्लीट क्विक सॉर्ट को रिप्रेजेंट किया है, हाउ इट इज रनिंग। सो दिस थिंग इज नथिंग बट अ रन टाइम लेआउट, हाउ we are calling quick sort again and again, uh, like that. So all this information is stored into a data structure called as a runtime stack that we shall see later. So every instance is called as an activation. So here blue arrows are given, 1 9 5 9 q 9 9. So these are the instances of activations, means that many times. So for example 3 arrows are there, 3 activations are there. तो प्रोसीजर एक ही है, प्रोसीजर इज ओनली वन, एक ही कोड है हमारा क्विक सॉर्ट का, लेकिन हमने उसको 3 बार कॉल किया लाइक दिस, और 3 बार कॉल किया, लेकिन हर बार उसके आर्गुमेंट्स, उसके एक्चुअल पैरामीटर्स चेंज हुए, उसके आर्गुमेंट्स एक्चुअल पैरामीटर्स चेंज हो गए और उसका रिटर्न वैल्यूज हर बार अलग अलग आएगा एवरी टाइम. So there is one more concept that is called the data area that we shall see some other time. But whatever this tree is there, we can traverse it by the depth first traversal mechanism, and जो भी हमारा trace रहेगा, that will be the flow of control of execution of this particular program. So this is something called as a flow of control. हमको इसको depth first traversal से traverse करना है इस tree को. So activation tree corresponds to it represents calls, procedure calls during the execution of particular function like quick sort. Now one more theoretical point is there. What is the flow of control? The flow of control is again concept. So it again depends on actual program which is running inside the memory with the help of operating system. But broadly we can say that there are two things are there. The execution is sequence. Normally we run instruction by instruction any program. So control is at some specific point. So you are somewhere, you are running first instruction, second, third, fourth, like that. So you are somewhere. So that is a point. So that is called as a point, execution point. And from that, you can go next or you may jump somewhere. It depends. You can jump also, or you can go back like that. So control is at some specific program point, and control moves from one point to another point in well-defined order. So when procedure is called, control eventually returns to the point immediately following the place where the call was made. So you can imagine a jump or call instruction. So point is something where you are currently executing particular instruction. उसका जो रिजल्ट रहेगा उसके हिसाब से आपका नेक्स्ट पॉइंट रहेगा. So this is only assumption. So I don't want to say that all assumptions hold true every time. Normally, if there is ordinary program like some addition of something, so you run first instruction, second, third, fourth, and last instruction like this. So it goes sequentially. But if you are using procedures, functions, jumps, calls inside your code, then the control point may move backward, forward, like that. So this is something, uh, I hope we are understanding this. Now, before going ahead, because we want to understand what is the runtime environment, we have to understand what are the issues of the source language. Uh, I will list it. So there are broadly 4 to 5 issues are there. Uh, on these issues, the runtime environment depends. So runtime environment depends on source language issues or problems. So there are various languages and language features are there that affects the runtime environment or organization of the memory. The organization of data is determined by answering issues. As I told you, issue is nothing but it is actually problem. So वो प्रॉब्लम के जो आंसर है उसके हिसाब से हमारा रन टाइम एनवायरनमेंट रहेगा. So what are those questions? So these are the broadly four issues, four problems are there. So we call this as a source language issues. So source language issues that affect the compiler. So does the source language allows recursion? Yes or no? If it allows recursion, then your runtime environment will be different. How the parameters are passed to the procedures means you are doing call by value, call by reference, call by text, like that, or call by value reference. So how you are passing the parameters to the procedures, also the answer to this question also affects the runtime environment. Then third issue is there, does the procedure refers to non-local names? Non-local names means name of the variables or data structures inside the code. So can you handle the local variables? Can you handle the global variables, like that? Does the language support the memory allocation and deallocation? So that is again there. For example, in C, there are some functions like malloc, calloc, allocate. So these are the functions. Malloc, memory allocate. Alloc means allocate, and deallocate is there. You can deallocate uh, memory location from particular variable for particular structure. You can free the memory. You might have learned about the garbage collection and all that. So whether we are doing it dynamically or statically. So does the language support memory allocation and deallocation dynamically, or you are doing it statically? So these are the majorly broad four problems which affects the memory layout or runtime environment. And these are the details. For example, can procedures be recursive? What happens to the values to the local variables on return? Means अगर प्रोसीजर रिटर्न होता है तो उसका वैल्यू कैसे पास होगा? Can procedure refer to the non-local variables? How parameters are passed to the procedures? Can procedures be passed as a parameters? Means can you pass a procedure itself as a parameter? कोई फंक्शन एज ए आर्गुमेंट करके आप कोई प्रोसीजर को पास कर सकते क्या? यस और नो, लाइक दैट. कैन प्रोसीजर्स बी रिटर्न एज रिजल्ट्स? जैसे फंक्शन हैज सम डेफिनेट रिटर्न वैल्यू, प्रोसीजर में वैसा नहीं है. प्रोसीजर में वैसा नहीं है. कैन स्टोरेज बी अलोकेटेड डायनामिकली अंडर प्रोग्राम कंट्रोल? मस्ट स्टोरेज बी डेलोकेटेड एक्सप्लिसिटली, मतलब ये प्रोग्रामर को करना चाहिए अलोकेशन एंड डी अलोकेशन, या ऑपरेटिंग सिस्टम खुद काम करेगा ये, लाइक दैट. सो दीज आर द ब्रॉडली जनरल इश्यूज that affects the layout of runtime environment. और हमने देखा what is runtime environment? It is nothing but it is some set of data structures like stack, data area, heap, like that. Now this is the general layout of any runtime image. Code is there, static area is there. Actually this is the area. Code is there, in that actual instructions are there. Static area is there, heap area is there, free memory area is there, and stack is there. Then we shall see what is the runtime stack and all that. I think I should end here, but I will go through 1, 2 slides and then we shall take another session to uh, cover this topic. Now, quickly, so this diagram on the left side is actually memory layout of your image, executable image. So, executable image is divided into these 5 parts: code, static area, heap, free memory, and stack. So target program runs on its logical space. We shall talk about it. The size of generated code is flexible, fixed at the compile time. The size of generated code means इसका complete size जो है is fixed by compiler. Compiler can place the executables at fixed addresses. So this is one assumption. The runtime storage can be subdivided into these 4 parts: target code, in code area, static data objects such as the global variables, local variables, stack to keep the track of the procedures activations. तो हमने पिछली बार क्विक सॉर्ट का एक्टिवेशन ट्री देखा. So there is something called as a runtime stack, which keeps the track of all the activations. Activation is for execution of particular procedure or function. And heap is there. It contains information regarding the data which is used in that program. So that is the area. Heap is the area where you store information about your data. Now this is a simplified slide. I will just end. And invocation of procedure P means execution of procedure P is called as the activation of procedure P. Now what is the lifetime? The lifetime of procedure P is that you are executing instructions first to last in that procedure. That is a lifetime, and including all the steps inside that procedure P. So this is called as the lifetime. Now lifetime of variables. So I have just tried to talk about it, but it may be, but you have to imagine that it is a text where you are using x. आज जहाँ पर भी आप x नाम का वेरिएबल यूज कर रहे हैं, सो इन दैट एरिया x इज ए लाइव, वो जिंदा है. वो एरिया के अगर बाहर गए तो x मर गया, मतलब इट इज ऑफ नो यूज. सो दैट इज कॉल्ड एज अ लाइफ टाइम. Lifetime of variable x is a portion in the code where x is defined and it is used. So note that lifetime is a dynamic, means it is a runtime concept. Lifetime of a variable is not a compile time concept, it is a runtime concept. जब आप प्रोग्राम रन करेंगे तो लाइफ टाइम उसका कहाँ से मेजर करेंगे? सोर्स कोड में से नहीं, जो आपका इमेज है एग्जीक्यूटेबल इमेज, वहां से हम लाइफ टाइम आइडेंटिफाई कर सकते हैं. सोर्स कोड में से हम नहीं कर सकते. सोर्स कोड इज अ सिंपली अ रिप्रेजेंटेशन, लेकिन एक्चुअल बाइनरी इमेज जो है हमारे कोड की, so that gives us idea about the lifetime. So it is a runtime concept, and scope is something there that we shall see. So activation lifetimes of a procedure can be depicted as an activation tree. We have seen in slide number 9. Now activation tree depends on the runtime behavior, क्योंकि हमको पता नहीं है कि when who is calling whom. For example, quicksort is calling itself. We don't know how many times it is calling. It is calling 2 times, 3 times, or 4 times. We don't know. So activation tree depends on the runtime behavior. So it depends on the particular point. The activation tree may be different for different programs. So activation tree is different for different programs. Now activations can be nested. They are nested. Matlab there is a procedure P. P is calling P. P is calling P. Then P is calling suppose Q. Q is calling suppose P, like that. So it is nested inside it. And this thing is maintained in something called as a stack. That is called as a runtime stack, or you can call it as a control stack. So since activations are properly nested, a control stack can be used to track the current activation, current active procedure. So we know that there is a procedure. When we execute that procedure, then we think that procedure is activation. Now, when this procedure calls another procedure, then इसका जो activation record है, it is kept into the runtime stack. So it is calling to another procedure. तो उसका activation record we are pushing into the runtime stack. That is calling another procedure like that. तो जो procedure खत्म होगा last में, we are emptying the stack while coming back to the code. So we push the information to the activation into the control stack by the procedure entry, and procedure का execution खत्म हो गया है, activation खत्म हो गया है, तो we pop the entry from that control stack or runtime stack. So let us take this example. This is a Q is a function and F is a function. So Q is a function which returns something, let's say 42, and F is a function where we are declaring x is equal to 0, and then we call G, sorry, it is G, and then we return F as a function F x minus 1. So let us say this is a sample program, and this is the actual code on the right side. So we have declared procedure G and F, and this is the main program. So what we are doing, we are running G program first, G procedure first, or G function first, and after G we are running F function or F procedure like this. So this is the main program. So itself it is a procedure. Main is calling G, and after G we are calling F like that. तो पहले क्या होगा, एक्टिवेशन कंट्रोल स्टैक में मेन का एक्टिवेशन रिकॉर्ड चले जाएगा, बाद में जी का एक्टिवेशन रिकॉर्ड चले जाएगा, उसके बाद में एफ का एक्टिवेशन रिकॉर्ड चले जाएगा. एफ का एग्जीक्यूशन कंप्लीट हो गया है तो हम एफ का एक्टिवेशन रिकॉर्ड उसमें से निकाल लेंगे स्टैक में से. फिर जी का एग्जीक्यूशन कंप्लीट हो जाएगा, उसका हम निकाल लेंगे, और फिर मेन का एग्जीक्यूशन कंप्लीट हो जाएगा, हम मेन को भी निकाल लेंगे. इन दिस वे वी गेट द एक्चुअल वैल्यू और रिटर्न वैल्यू. So the information needed to manage the single procedure activation is called as activation record, or you can call this as a stack frame. So please do not confuse with the word frame or stack frame or activation record. So activation record is nothing but it is a data structure which keeps the information about variables, local variables, global variables, parameters, arguments related with particular procedure or some function. So it is a data structure. Simply, it contains information about variables, data structures used by that particular procedure or function. That is called as an activation record. So it is simply a data structure. You can call it as a stack frame. Same thing. Now here, this is scenario that if a procedure F calls G, then G calls the activation record that contains mix of the information about F and G. So I will end here, but I wish to go to one slide. Now see, here there is a detailed program given in your book. You can see page number 431. So there is a function read array, there is another function partition, there is another function quick sort, and there is a main function. In main function हम क्या कर रहे हैं, read array को call कर रहे हैं, and read array calls other functions like partition and quick sort. And here is a sample possible activations. मतलब हम main में जाते हैं, then we execute read array को खत्म करते हैं. Read array calls, after read array we run quick sort. by giving actual parameters 1 9, मतलब 10 आइटम्स हमने इसको इनपुट दिए, तो so that will create one activation record. Then quicksort will run. Then it will create another instance of quicksort by values 1 3, like this. In this way we are calling quicksort again and again with अलग-अलग parameters, with different parameters, input parameters or arguments. And lastly we finish the main program. So this is sequence of possible activations of particular program, this quicksort. And in this way, if you understand this slide, then you will understand the activation tree, how quicksort is calling itself along with which parameters. So I hope you got what is the meaning of the activation record. Activation record is nothing but it is a data structure which keeps the information about the name of the procedure, arguments of the procedure, return values of the procedure, and जो भी उसके local variables है उसमें के हमने declare किए procedure में, everything is stored into that particular area. So in data structure that is called the activation record, and this is called as a activation tree. So it is showing the execution of instances of quicksort. So we have to traverse this tree in a breadth-first order. You will understand what is the flow of control of this particular execution of particular program. Now I will finish with 2 slides only. So I suggest you keep the definition of what is a frame or frame stack, what is activation, then what is a control stack or runtime stack, like that. What is the activation record? What is the data area? You can get the definition from that book. So procedure calls and returns are usually managed by the runtime stack. As I told you, when there is execution of particular procedure, so operating system maintains something called the runtime stack. प्रोसीजर का कॉल आपने एग्जीक्यूट किया है तो उसका जो एक्टिवेशन रिकॉर्ड है पर्टिकुलर प्रोसीजर का वो हम रन टाइम स्टैक में डाल देते हैं. जैसे जैसे हम प्रोसीजर अलग अलग प्रोसीजर्स को हम रन करते हैं तो उनके एक्टिवेशन रिकॉर्ड हम रन टाइम स्टैक में डाल देते हैं और वो पर्टिकुलर कॉल खत्म हो गया है तो उसका एक्टिवेशन रिकॉर्ड हम निकाल लेते हैं स्टैक में से, लाइक दैट. So this thing is called as a runtime stack. So each live activation has an activation record, sometimes called as a frame, on a control stack with the root of the activation tree at the bottom, and the entire sequence of activation records on the stack corresponds to the part of the activation trees. The activations where control current means we can understand where the control is flowing, flow of control. So anyway, the activation record looks like this. So it is again data structure. It contains 1, 2, 3, 4, 5, 6 and 7 things. So actual parameters जो हम उसको पास करते हैं, argument 1, argument 2, argument 3, return values जो मान लो return x है तो return value है x यहाँ पे रहेगा. Control links, some pointers to those variables or structures used in that access links. Then saved machine status, program status रहता है PSR, local data and some temporary variables can be used by that particular procedure. So while computing that procedure or encoding that procedure. So in this way 7 or 8 things are there in activation record. This is theoretical. It doesn't mean that it has only 7 things. It may have 8 things or 9 things. So in short, it contains temporary values or temporary variables, local data or local variables, machine status, access links, control links, मतलब जंप करने के बाद में कहाँ when there is a call, we have to jump somewhere on some location. या फिर return address रहेगा, you have to return. There's, there is a space means where return values are stored into the memory, and actual parameters used by the calling procedure. So these are the 7-8 things are there which are stored into the activation record. So activation record is associated with the activation of a procedure. Activation of procedure मतलब क्या है? Execution of particular procedure. Execution of procedure is called as activation, or activation. Execution of procedure contains, we have to update something called as the activation record. Activation record contains data about that particular procedure. It is data about procedure, variables and items, arguments. So in this way, you can imagine what is the runtime stack looks like. पहले इंस्टेंस पे जो भी एक्टिवेशन रिकॉर्ड है हम उसको रनटाइम स्टैक में डालते हैं, दूसरे एक्टिवेशन को डालते हैं, तीसरे इसको डालते हैं, लाइक दैट. फॉर एग्जांपल मेन इज कॉलिंग एफ इज कॉलिंग जी, लाइक दैट. So friends, I am closing here. We shall see remaining part. I will schedule one more meeting. I will send you WhatsApp message. I hope whatever, but you got the concept of the runtime environment. Runtime environment depends on the features of particular programming language. What are the features like passing parameters and all that. So I will stop here.